So, hi, good day. My name is Wolfgang Disselhoff. I'm solution architect at Dremio. And today I would like to talk about Lakehouse with Dremio. Let's review the agenda. So, what is the problem that we solve? Let's dive into that. Then, where do we fit in the OSS world? And after we are clear on what we do, I would like to jump in a short demo and to show you how it looks like. How is the feeling with that? So, what is the problem? So, we have in the basement, we have cloud data lake storages that many companies use to store the ever-growing continuous new data. It's Azure Data Lake, it's S3, it's Google Cloud Compute Storage, or it's HDFS. And what you do with that vast amount of data, you start to build complex processes where you bring this data in, e.g., Snowflake or other environments, to make it data warehouse-like retrievable. And with that, you probably start to do extracts, cubes, aggregations to fit to the BI users or data scientist requirements, to give them a subset or cost-wise. So that is the area where you have a decreasing data scope and flexibility. So reduce, you aggregate, and see that you can fulfill all the requirements that are there. This is a complex process that you set up. You need to set it up, to change it, to maintain it, to monitor it. And it's more and more getting operational. So complexity is even growing with each new data source that you have. And this takes not only a lot of money, this takes weeks or months turnaround time that you really cover changes, new data that arrives, or need to change the progress chain. So how to solve it? What Dremio suggests is go for a no-copy architecture. So we still have the same cloud data lake storages that have a lot of benefits in the infinity of size, in low cost, and you continuously get new data there and add to your existing data sources, continually growing data. Dremio brings now a SQL engine to access this data direct. When we talk about really massive data sizes, we bring in a query acceleration. You make the data consumable as fast as possible, and I show it in the demo afterwards. And on top, you will get a semantic layer that consists of all the data sources that are on a data lake. So it adds information to that, as well as access rights, role-based access to the sources, regardless what is below there and where it comes from. So, and that is a self-service layer for your data scientists, BI users, and we do not copy the data. We leave it where it is, as it is, and we only get you the self-service performant access to it. With that, you get rid of complexity, you get rid of complex chains that you need to manage, monitor, change, and you get full data available for your analysis, which is even important for data science discovery phases. And this takes hours and not more like that to make your data available or to get changes to your consumers instead of weeks, days, weeks or months. So who is Dremio? We are a startup, and we reached recently unicorn status, and we are partnering with all the players in our ecosystem. We make our money with enterprise customer adoption. These guys go for our software and allow us to do to work in source innovation. So what we are working for is Apache Arrow, which is a columnar representation, a columnar in memory representation of data, and which allows vectorized computation as well. The other thing that we offer is Nessie. That is a Git style, or we introduce and work for, is Nessie. It's a Git style approach to work with data. So if you have your data on a data lake, you do what you do in Grid. You create a branch, you work on the branch, progress the branch, you have steps in that. And after you're fine, after you've done with that, you can merge it back to your main data stream. So it's a huge difference to what you do today. So we see 20 million downloads by month for Flight. Flight is a protocol to deliver columnar data in parallel to clients to overcome JDBC or ODBC shortcomings, and actually last month was more than 40 million downloads. So this shows that there's a rich ecosystem. It shows there's really a place where this software innovation fits to your needs. Besides that, we host 2 times a year the Subsurface, a cloud data lake conference, and where we talk about data lake, how to access it. We talk about innovations, and the customers report mainly what they do in cloud data lake area. I'm happy. I would be happy to see you there. Feel free to go for the Subsurface conference and be part of this community. So we talk about open source. We talk about the open data architecture. You have your storage with S3, ADSL, GCS, or HDFS, or other ways to store your data. There are files stored. We love Parquet. You can do JSON, CVS, and some more. On top of that, you will find table formats like Apache Iceberg or Delta Lake, which allow you to do this Nessie style of work, which allow you to do data warehouse style of work with your data lake. And for the metadata, we use Project Nessie, AWS Glue, Hive Metastore to make data available to all your parties and to all your consumers that are in your environment. So with that, we make sure that you have the flexibility to use the best of breed engine. There is no vendor lock-in. The data stays as you put it on a lake. There's no change with that. So you're open to the future. This is multi-cloud or even on-prem, so you have all deployment options that you want to have, and you can bring together data from all clouds and all storages as you want. And think about back, have a semantic layer on top of it, and have a security layer on top of that. And there's a very important quote from Werner Vogel, CTO of Amazon. And I would like to just pick from my point of view, important piece. Open formats also make it more likely for the data to be compatible with tools that don't even exist yet. It means we are on a way to get more and more abilities to analyze data. And what you want to have is your data as it is open, accessible for everyone in your environment, and for everything that is not even available today, but you need tomorrow. So think about that, how to stay with open source innovation, with open formats, and don't lock your data to anything else. With that, I would like to jump in a short demo. My demo setup looks like this. We have one part that is a data consumer, where we just browse to the semantic catalog, identify a set of data, New York City taxi rides, and use Tableau to analyze it. The second part of my demo, I would like to change the roles. And what we do is that we carry the head as a data engineer, that we use to modify, to change some data. And again, no copy, so to work on the representation of the data. So what I have set up is an Azure Data Lake storage, in the Postgres database for the second part. We have a cluster of 4 execution engines. And in my case, I have a Tableau installed on my Mac that I would like to use to visualize the data. Let's jump into it. So I logged in my web-based application to Dremio, and what I see is my personal workspace, and we call it Spaces. And what I see is the wiki, the semantic enrichment that you can do on all your objects in Dremio, on the workspaces, on sources, on tables, on views, whatever you have. In this area, you are, for example, able to upload some data to your personal space and make it available in the data lake as well. On the left hand, we have spaces that are the organization units that you use to create your semantic layer. So we have a space for applications, business, and others where that are work like folder and subfolder. You see you have data in there, and all the data can, for example, have privileges and some more options. And this is role-based access that you apply to that. So going back to my space, I would like to act now as a BI user. And I'm looking for a New York taxi. I just query my semantic catalog, and what I will see is these purple entries, which indicate this is really the raw data, or this green element, which is a virtual data set, which means there is something processed, something is prepared for me. And if you have no access right, if you're not intent to use this data, you wouldn't even see it. So I'm not sure which one to use. That is too much for me. So my colleagues did too much demos on that. So I use a tag, and you can use anything to query. So I use a tag to search for it. And what I see is New York City trips, gold. That is the one I would like to use. Go for it. Remember that we use SQL to access the data lake. The files that we are reviewing right now, or the data that we're reviewing right now by simple SQL, are Parquet files on the Azure Data Lakes. We review 80,000 records here, and what do we see? We have a vendor, a pickup date, drop off passengers, where was the location from to, and what was the payment, the tip, and the total amount. Okay, that's the data that we would like to work with. We now just click the button for Power BI or for Tableau, and we will get a business TDS file to get into Tableau, which contains all the metadata, the connection information we just use it. I already started Tableau. That's the way it comes up, exactly this. And you see here the metadata that was provided. And let's start to work with it. So now we change from Dremio to Tableau to analyze data. And what I would like to do is do a simple count on this information. So what we see with less a second, we have a count, and the number of data that we're working on is 1,025 million. So a vast amount of data that we are looking for. So let's see how this data develops over time. Use a pickup date, and we see we have data from 2009 to 2014, and where we nearly evenly distributed. And I would like to analyze the tip amount. Okay, we have a tip amount. We have the sum of tip amounts. That's probably not what is likely to analyze. So let's go for an average. And as well, we are working on 1 billion rows. And maybe we go deeper to a quarter, see how this develops over a quarter. That's very nice. And let's see how it is on a day rate or on a daily base. Okay, and here we see much more details that is maybe worth to analyze. We have lows, we have peaks, and we can see how our tip develops over that. We have a drop in tip, and maybe here's some error, but here are probably some events that are worth analyze. So what I would like to demonstrate and show to you, how you can use Dremio to analyze a set of Parquet files on a data lake that sits somewhere and establish a fantastic acceleration that you really can work on a vast amount of data. In our case, a billion rows here, and that gives your BI users a different experience than you would like to have with any other data warehouse or the database, something like that. So with that, I would like to go back to Dremio and show you a little bit how we are able to speed up these billion row queries. And we have reflections. Think about reflections like an index or a materialized view, something like that, that do not need to show the full query, which can show parts. In our case, you use the aggregate reflection, where we define dimensions and measures which can use. So we are not only accelerating a single query, we're accelerating the access to the data. This is a small footprint. It took around about 2 to 3 minutes to refresh this footprint. And last time I get lost. My last demo, the aggregation was lost. I need to recreate it, 2 to 2 minutes. And the aggregation itself, the speed to get the data itself was very nice as well, because we use Arrow to access in parallel the Parquet files. We do not need to serialize or deserialize the data. We put it in data in memory. We work on memory in it, and we can use Arrow flights to bring the data to the clients. Besides that, we have 4 or any number of engines that parallel process the data, which can have local cache as well for, let's say, repeated queries that you maybe have in your environment. With that, I would like to go back and go to the second scenario. Now we change the head. Now we are data engineer and we need to wrangle some data and have a small table, employee data in, let's take this one. Employee data in a Parquet file on a corporate S3. Let's go for that. That is a native naked data, purple color, a physical data set. And what we see here is the employee ID, first name, last name, email, phone number, a department ID. So I would like to change the email to a proper email that we can use. And I start with a very simple thing, convert case, put it to lowercase, apply it. And yeah, that works fine. Next thing I would like to do is do a calculation with this field to add a domain to that. We have a lot of anti-SQL functions that we can use, even to pivot data or deconstruct JSON file fields, or whatever you would like to do. And all these functions work in your SQL on any data source that you have below that. Let's go for the concatenation. Email. Oops. That looks good. Let it apply. So that is the way how to work on data. You could change the salary to mask it, things like that. The next thing I would like to do is join the department ID to a Postgres database. Let's search for department. And what I have is department on the Postgres public database or public schema on my Postgres database. Oops. That's one. Yep, that looks good. Next, I would like to join on a department ID on this side, department ID on that side. That looks good. And apply it. So what we did right now is that we joined Parquet files on a S3 data store with a Postgres database. And we got the results that we would like to have. And now what we do is save as. What you see is the save data set as. It doesn't mean that we copy the data or something else. So we just save the representation as a SQL code that we created to a file name, to a virtual data set. Employee. And we save it to a space that we have. Let's say, go to the solution architects, see where we have Wolfgang, and put it from dev to test, and save it. Okay. And save it. So we save the definition, the data stays where it is, and we do not change or copy it. What you could do now, use a catalog, add wiki content to that, review the graph, how is it built? So we see the sources, the S3, the Postgres, the physical representation of the data we cached, and the join that we have, and we would see some more information. And now we could say that is very nice. We would like to add a raw reflection to that, or an aggregation reflection to speed up the access. By the way, this data, then the reflection data, the pre-calculated values that we have, that will be stored on the data lake with a very fast access in Parquet files. So with that, I hope I can demo a little bit Dremio, how it works, how is the look and feel. Would like to go back to presentation. So what we saw is faster time to value. You simply click together the definition of what you want to have. You can use anti-SQL. Most of the people are trained to do that. You will achieve that your data engineers are more productive. Your consumer are sufficient to do more and to find the data faster with the governance, with the semantic layer, with the wiki content, or with the labels that you put on top of it. And by the way, by not copying data and having steps and processing engines, you significantly reduce your data infrastructure cost and the complexity and the time to solution. So you unleash, from my point of view, you unleash creativity to make your business more successful. Thank you very much. I'm happy to get contacted. Feel free to contact me even for the subsurface. Thank you very much and have a great day. Bye-bye.